Okay, for this second section of graphing quadratic functions, we're going to look at the a value. Last day we looked at what happened when we added a p and a q to the x squared value, so today we're going to look at what happens when you had the a. Remember, the p and the q caused a translation to the graph. The p moved the graph left or right, q moved it up or down. And the p and the q ended up also giving us our coordinates for the vertex of our graph. So we're going to check out today what happens when you throw in an a value. And the a value goes in front of the x squared term. So the first part says graph y is equal to x squared using the count method. Last day when we did this, the count method, if you recall, was when you would go over 1, up 1, and then we went over 2, up 4, and over 3, up 9. I'm just going to squish that in there because I'm running out of room. So however many over you went, you went a squared amount up. Our vertex for this one, when it was just y is equal to x squared, was at our origin at 0, 0, because our p value would be 0 and our q value would be 0. So just to refresh doing the actual graphing, you put your vertex in, this one at 0, 0, and then do your over from the vertex. So over 1, up 1, puts us there. Over 1 on the left, up 1, puts you there. And then you do your over 2, up 4, over 2, up 4 to the left. Over 3, up 9, and over 3, up 9 to the left. Join your dots, and you have your graph. So now we're going to see what happens when we put a value in front of that x squared. So in this case, our value is a 2. So if we look at our table of values and use the ones that are given there, for this one we would be doing y is equal to 2 times negative 3 squared, which would be 2 times 9, which would give us 18. Negative 2 squared would be 4 times 2 would be 8. Negative 1 squared is 1 times 2 is 2. 0 squared is 0. And multiply that by 2, you get 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 3 is 18. So now if we go and plot those ones, and I'll do that in another color. So we start at negative 3 and 18. Well, I don't have quite up to 18 on this one, so I'm just going to move it up a bit, and we'll set it somewhere, say up here. Negative 2 and 8 puts me here. Negative 1 and a 2. And then we were at 0, 0. And then over on the right side, 1 and 2. 2 and 8. And then again, 3 and 18, which we'll set up there. So you join your dots. And what do we notice between the two parabolas? Well, the parabola with the 2 in front of it has gotten visibly narrower than the one that just had a value of 1 in front of it. So we notice that the parabola got narrower as it moved upward. It started at the same point, but it got skinnier as we put more values into the x squared, and that was due to multiplying by that 2. So that's called the a value. And the a value will change the shape of the parabola by making it either narrower or wider. So in this case, we got narrower. Okay, so if we try doing this one for y is equal to 1/2 x squared using the count method instead of a table of values. So if we look at our y is equal to x squared just at this part here, we don't have a p-value, so we know p had to equal 0, and we don't have anything being added on to that squared, so we know that our q had to be 0 as also. So that means our vertex is at 0, 0 for this graph as well. If we look at the a value, do that one in. The a value here is 1/2. So what's going to happen then is all of our counts going up are going to be halved. So we're either going to multiply by half if you want to think of it that way, or divide by 2. So instead of doing over 1, over 1 up 1, we're going to do 1 times that 1/2. So we're going to go over a half, or sorry, up a half spot instead of up 1. So that means if we do our over 2, normally we would go up 4, but we have that half value to think of, so we have to half that 4, so we're going to go up 2 instead. So if we go over 3, we would have gone up 9, but we have to go half that amount, so we're going to go up 4.5. And because these are such small values, we can go one more. We'll have room on our graph, so we'd go over 4, up normally 16, but this time we're halving it, so we'll go up 8. So now we can plot those points. So you always start at your vertex. We said vertex is 0, 0. So that's where we're going to be starting. And now we'll do our counts. So we're going over 1, up 1/2, over 1, up 1/2. Over 2, remember we always go back to the origin or to the vertex, so over 2, up 2, and then over 2 to the left, up 2. Then we go over 3, up 4.5, so over 3 up 4.5 is about there, and over 3 to the left, 4.5, puts us about there. And then the last one we did was over 4 up to 8. So then we do the same on the left, over 4 up 8. So then we connect our dots this way. And we have our parabola all finished. So what did we notice with that one? Our a value was 1/2, and our graph got wider. When a was a value of 2, our graph got narrower. So the a value is going to affect our counts up. We're going to be multiplying by whatever the a value is, and if that a value is greater than 1, it's going to make our graph a fair bit skinnier than normal, or if it's less than 1, it's going to make it wider than normal. One thing you might want to do for these graphing lessons that I don't know if I've mentioned is to use different colors when you are drawing the graphs like this when we're doing these lessons, because then you can see the comparison of them and you know which graph goes for which example. So the a value. We found out that it alters the shape of the parabola. So what we do is we have to multiply the a value to that up count. So what if we have y is equal to negative x squared? So if we do our table of values for this, whatever our answer is, whatever we square, we're going to have to multiply by a negative. So we have y is equal to negative 3 all squared, so that's negative 9. So we'd have negative 9, negative 4, negative 1, 0, negative 1, negative 4, and negative 9 for values. So all I did was square the value and multiply by that negative. So either by looking at the equation or by looking at our table of values, we can see that our vertex is 0, 0. From the equation, we can see it's 0, 0 because nothing is being added inside the bracket for a p-value, and nothing is being added to the outside for our q value. So our vertex is at 0, 0. From last day, we found our axis of symmetry. The equation for that was always x is equal to p. So we've found out from here that our p is 0 and our q is 0. So then that means our axis of symmetry is x is equal to 0. So we'll draw the graph and see what the maximum, minimum, domain, range are. So starting at negative 3, we go down to negative 9. Negative 2 put us at negative 4. Negative 1 put us at negative 1 and 0, 0. Then on the positives, we have 1 and negative 1, 2 and negative 4, and then 3 and negative 9. So our graph takes on a look like this. If we draw that axis of symmetry, remember that's just that dotted line that cuts our graph in half. And you can put arrows at the ends if you want. It's not a big deal for those if you don't. You just have to remember you always put arrows at the end of your parabolas, and you always put arrows on the ends of your coordinate planes and label them. So by looking at this graph, we can tell that we have a maximum point because the graph is pointing down. So if the graph is pointing down, that means our y values can only get up so high, and then they won't be able to go any further. They're going to start going back down again. So in this case, for this graph, we have a maximum at, and last day we said the maximum is at whatever our q value was. So our q value for this one was 0. So we have a maximum at y is equal to 0. Our domain, we just went between the values of negative 3 and 3, but we could have gone further in both directions. So our domain is the set of values for x such that x is an element of real numbers. And for every graph that we're going to do, unless they specifically give you values to use and say that this is the stipulations or these are the boundaries, it will always be all real numbers for domain. Our range then is a set of values for y such that y, and looking back at our maximum or minimum, we said it was a maximum, so everything has to be below or less than that maximum value. So y is going to be everything greater than or equal to 0. And again, we could add in there that y is an element of real numbers, but since we know we're using real numbers, you don't need to put it in for that range part. So the range also uses that q value to help find what it would be. Oops. So the negative a value there, if we look at our graph, the negative from, if we compare it to the x squared graph, The only thing that is different is that our graph is going down. So the a value, positive or negative, will tell you which direction your graph is going. So that negative a value causes the parabola to open downward. Positive a value, like we saw in all the other examples, made our graph go up. So if you're looking at your basic count when you have a negative a value, it'll stay, if your a is a 1, but a negative 1, your basic count is going to be over 1, down 1. Over 2, down 4, and then over 3, down 9, and so on. It would just keep going on. So you're still squaring the value if it's just a 1, but if it's a negative, it's going to go down instead of up. So what happens if we have y is equal to negative 2x squared? So we know from before, nothing is being added or subtracted onto this, so we know we have a p-value of 0, and we have a q-value of 0, and now we know we have an a-value of negative 2. So using the count method then, we know that this graph is going to open down because of that negative value. And what we said is whatever the a value is, you multiply it to that count up or down. So our count for this one will be over 1, down, it'll be 1 times that negative 2, so it'll be down negative 2. Over 2 then would be down normally 4, but we have that negative 2a, so it's going to be down negative 8, or down 8, I guess. And then over 3 means that we're going to go down. Normally be 9, but we have that negative 2, so we go down negative 18. So when you do your graphing, you go from your vertex, 0, 0, and then start your count from there. So we went over 1, down 1. Sorry, this one's a 2. Over 1, down 2. And then back over 1, down 2. Back to the vertex, over 2, down negative 8. Back to the vertex, over 2, down negative 8. And then if we did the 3, we'd go over 3, down negative 18, which would be somewhere way down here and way down there. So you connect your dots. Whoops, that was a bad one. Not much better, but that's what our general graph would look like. So for a graph to be in standard vertex graphing form, the equation looks like this. Y is equal to a times x minus p squared plus q. Our a can be positive or negative, the p can be positive or negative, and the q could be positive or negative. What we know is that the a will tell us if the graph is going up or down. It's going to alter the counts, which means it's going to make it wider or narrower. If it's greater than, I'm going to think of absolute value. If it's greater than 1, it's going to be narrower. If it's less than 1, so fraction between 0 and 1, then it's going to be wider. So it alters the count, which alters the shape, and it also will tell us if we have a maximum or minimum graph. The p-value here, when we do, remember we always do that mental switch sign for it. So we mentally switch the sign. It's going to give us the x-coordinate of the vertex, which means that it moves the graph left or right. So when you pull that p-value out, if the equation was x minus 2, our p-value, do that mental switch of the sign, so it would be a positive 2, so that means the graph would move to the right. And it also is the axis of symmetry value. The q value then, we don't have to switch the signs. So if the equation was a minus 3, then our q value would be negative 3. So the q value translates graph. Remember, and translate is the same thing as move up or down. And it gives us the maximum or minimum value. Okay, and that always is at y is equal to q. So our vertex is always at PQ, axis of symmetry. Is always x equals p. Your max minimum depends on A being positive or negative. And it always occurs at y is equal to q, which helps us with our range. And it's either going to be greater than equal to or less than or equal to q. Oops. Depending if it's a maximum or minimum value. So now we're going to take a look at this and put it all together. So the equation says the function of x is equal to 2 times x plus 6 all squared minus 3. So you have to remember that function of x means the exact same thing as y is equal to. Okay. So by looking at this graph, or by looking at this equation, we can find our vertex, we can find our axis of symmetry, we can see if it's a maximum, minimum, we can do the domain and range. And that's just by looking at the equation. We don't even have to graph it to find those things out. But we will graph it once we find all those things. So, starting with the equation. Oops, I'm just going to change my color. So f of x is equal to 2 times x plus 6 all squared minus 3. So you always start out when you're given the equation by identifying what is A, P, and Q. And once you have those, you can fill in everything else for your information, and then you can do your graph. So my A for this one is a 2. My P, it's a +6, so I always do the mental switch, so it's -6. And my Q is -3. So that means my vertex is at -6, -3. Axis of symmetry was x equals p, so it's x equals -6. Maximum or minimum means I look at my A. A is positive, so that means I'm going to have a graph going up. So it's an A plus or an A positive, so my graph's going up, so I have a minimum. And my minimum is always at y is equal to q, so it's -3. Domain, always the same, a set of values for x such that x is an element of real numbers. My range, I take a look at my A value. My A value is positive, so I have the set of values for y such that y is, if it's a minimum or positive A, my graph's going up. So everything for my y has to be greater than or equal to my q of -3. So now I have that information, I can graph it. But what I need to do is just fill in what my count would be. So for this one, because my A is equal to 2, my count is going to be over 1, up 1 times 2, so it's up 2. Over 2, up 4 times 2, so I go up 8. Over 3, up 9 times 2, so 18. And then over 4, up 16 times 2, so it'll be a 32. I probably won't do that one. So let's graph this. So I start at my vertex. Always start at the vertex. So -6, -3 puts me here. 5, 6, 1, 2, 3. Then I do my counts. Over 1, up 2. Back to vertex. Over 1, up 2. Over 2, up 8. 2, 1, 2, 3, 4, 5, 6, 7, 8. And then over 2 left, up 8. And then I do my 3, over 3, up 18. Am I going to quite get there? It'd be close. 1, 2, 3, that was 8, 9, 10, 11, 12, 13, 14. So 18's it's going to be a little bit higher. And then over 3, up 18. So I connect my dots. Put my arrows at the end, because again I could have kept on going, but I stopped there. And I draw in my axis of symmetry at x is equal to -6. And I'm done. So the next one was y minus 4 is equal to -1/2 x minus 5 all squared. This is not in vertex graphing form. Vertex graphing form has to have y by itself and everything else on the other side. So that means I have to move that -4 over. So if I start with y minus 4 is equal to -1/2 x minus 5 all squared. I add 4 to both sides. So I have y is equal to -1/2 x minus 5 all squared plus 4. So for this one, again, once you've manipulated your equation so it's vertex graphing form, you identify A, P, and Q. So for this one, I'll do it over here. A is equal to -1/2. P is equal to +5 because it was negative in there. And Q is equal to 4. So remember, this a value here, it's negative, so that means my graph is going to be going down, and my count is going to be multiplied by that 1/2. So I have to keep those things in mind when I'm graphing that. If my a is negative also, that means that because my graph is going down, I'm going to end up with a maximum value. And these things here are, you don't need to write those in, it's just things to keep in mind as you're doing the graph. So my vertex is PQ, so vertex is at 5, 4. Axis of symmetry, x is equal to p, so it's x is equal to 5. I said from before my a is negative, so that means I'm going to have a maximum at y is equal to q, so y is equal to 4. Domain, always the same, set of values for x, such that as x is an element of real numbers. My range now, because I have that maximum, it's going to be the set of values for y, such that y is going to be everything less than, because it can only reach that maximum value, so it's going to be less than or equal to q, which is 4. So then the only thing left is the count. So normally I would go over 1, up 1 squared, but this time I have that 1/2. And I wrote down up, but actually because it is negative, it's going to go down. And again, it doesn't really matter when you're doing this if you write this in as a positive 1/2 or a negative 1/2. I'll just leave it as a negative just to keep consistent from last example. So over 2 normally would be down 4, but I have that negative 1/2 a, so I have to multiply it by negative half, so it'll be a negative 2. Over 3 would be down 9, but I have that half, so it's going to be negative 4.5. Over 4 means I would go down 16, but I have my negative 1/2, so it'll be down a negative 8. And that should be enough values to graph. So let's start our graphing with our vertex at 5, 4. So we count 5 over to the right and 4 up. Puts us right there. And then you do your counts. So the first one was over 1, down 1/2. And then to the left of the vertex, over 1, down 1/2. Back to the vertex, over 2, down 2. Back to vertex, over 2, down 2. Over 3 from vertex, down 4.5. And then over 3, down 4.5. And then we threw in that last one of over 4, so it was over 4, down 8. And then over 4 to the left and down 8. So you draw in your graph. Put your arrows, axis of symmetry. And the axis of symmetry should be at x is equal to 5, and it is. And you're all done. So for this part, we're going to stop here so that you can work on graphing these equations. So the questions that would go with this one are questions page 157, 4, 6, and question 7c was what was assigned. So you can get started on these, or you can wait for class to work on them. I also have another set of questions for you to work on with these that we will be doing in class to do with graphing them and with identifying all those characteristics.